Double tapping breakers is prohibited by the National Electrical Code because it can cause overheating, which could lead to an electrical fire. Each circuit breaker is designed to handle a certain amount of current, and when two wires are connected to a single breaker, the combined current can exceed the breaker's capacity. This can cause the breaker to trip or, in extreme cases, to overheat and catch fire. The NEC also requires that each conductor have its own overcurrent protection device, such as a circuit breaker or fuse. Double tapping breakers violates this requirement, as both wires are connected to the same breaker. In addition, double tapping breakers can make it difficult to troubleshoot electrical problems. If one of the wires connected to a double tap breaker trips, it can be difficult to determine which wire is causing the problem. This can lead to wasted time and effort, and it can also increase the risk of an electrical fire. For all of these reasons, it is important to never double tap breakers. If there is a need to add a circuit to the electrical panel, a new breaker should be installed or replace the existing breaker with one that has a higher amperage rating. A deeper dive into why double tapping breakers is not permitted will involve numerous factors, all centering around electrical safety and compliance with the National Electrical Code. Firstly, consider the design and listing of circuit breakers. Circuit breakers are engineered, tested, and listed by organizations like Underwriters Laboratories, or all to perform within very specific parameters. This listing includes the number and size of conductors that can be safely and reliably terminated at the breaker. Connecting more conductors than the breaker is designed for violates its listing and compromises its ability to function as intended. Secondly, termination capacity plays a crucial role. The terminals on circuit breakers are designed to provide a secure and reliable connection for a specific range of wire sizes and a specific number of conductors. When multiple wires are crammed into a single terminal, it's difficult to achieve a proper torque in the screw or clamping mechanism. This can result in a loose connection, increasing resistance and generating heat. Over time, this heat can degrade the insulation on the wires, damage the breaker itself, and potentially ignite nearby materials. Thirdly, current carrying capacity is a major concern. Each circuit breaker is selected based on the calculated load of the circuit it protects. The breaker's amperage rating corresponds to the maximum amount of current that the circuit is designed to handle safely. When two separate circuits are combined onto a single breaker through double tapping, the total current flowing through the breaker can exceed its rating. This can cause the breaker to trip frequently, but more dangerously, it can also cause the breaker to overheat without tripping, leading to a fire hazard. Fourthly, NEC regulations explicitly address this issue. The National Electrical Code provides detailed requirements for the proper installation and wiring of electrical systems. While the specific wording may vary depending on the edition of the NEC, the general principle is that each conductor must be terminated in a manner that is consistent with its listing and that ensures a secure and reliable connection. Double tapping breakers violates this principle because it involves connecting multiple conductors to a single terminal that is only designed for one. Fifthly, consider the impact on troubleshooting. When a circuit breaker trips, it's important to be able to quickly and accurately identify the cause of the problem. With double tap breakers, troubleshooting becomes significantly more difficult. It's not always clear which of the two circuits connected to the breaker is experiencing the overload or short circuit. This can lead to wasted time, unnecessary repairs, and increased frustration. Sixthly, there are alternatives to double tapping. If additional circuits are needed in an electrical panel that is already full, there are several code-compliant solutions available. One option is to install a new electrical panel with more breaker spaces. Another option is to use tandem or duplex breakers, which are designed to allow two circuits to be installed in a single breaker space. However, it's important to note that not all panels are designed to accept tandem breakers, and the panel's labeling must be checked to verify compatibility. Seventhly, consider the legal and insurance implications. Electrical work that is not performed in accordance with the NEC can have serious legal and insurance consequences. If a fire or other electrical incident occurs as a result of double tap breakers, the homeowner may be held liable for damages and may have difficulty obtaining insurance coverage. Eighthly, the wire size and breaker size correlation must be considered. The National Electrical Code Table 310.16 dictates the allowable ampacities of insulated conductors rated up to 2000 volts, 60 degrees Celsius to 90 degrees Celsius. For example, using the 75 degrees Celsius column, a 14 American wire gauge copper conductor is typically rated for 20 amps, a 12 American wire gauge copper conductor is typically rated for 25 amps, and a 10 American wire gauge copper conductor is typically rated for 30 amps. Ninthly, breaker torque requirements is a factor as well. Each breaker has a specific torque requirement that ensures the wire is held in place properly, so it makes proper electrical contact and so it is safe. Tenthly, wire insulation damage can occur when double tapped. When two wires are under one lug, the insulation can rub and be damaged, exposing the bare conductor. 11thly, professional electrical inspections are vital. A qualified electrician can inspect the electrical system to identify any potential hazards, including double tap breakers. They can also provide recommendations for correcting any deficiencies and ensuring that the electrical system is safe and code compliant. In conclusion, double tapping breakers is a dangerous and prohibited practice that could have serious consequences. It violates the National Electrical Code, compromises the safety and reliability of the electrical system, and increases the risk of fire. If additional circuits are needed, there are several code-compliant solutions available that should be used instead. By following these guidelines, one can help to ensure the safety of themselves and their property.